Okay, taking a look at some of our challenges we've got ahead of us in deciding our approaches. I've got this little copy example set up here, and just to illustrate, we want to try and think of ideas how we're going to copy the geometry across the top surface of the walkway, and then we can progress to the sides, etc. So first of all, let's say we've got this grid, and imagine this is our walkway top. We want to be able to scale it up and down. Obviously, this is simple. We would want curves, corners, and stuff like that, and how we're going to deal with that. But I've brought in my little packed piece of geometry again, just deleted out the proxy stuff again, and then just isolated one. So first of all, we've got this straightforward copy, and we can obviously try and do a bunch of copies like this, and then we can control the spacing to get them to overlap and line up, and then we could get the next line and try and copy that way by rotating stuff. We can also rotate stuff at like 180 degrees. That will give us some extra variation, but obviously this isn't really ideal for a larger scale system to be able to do that, because you're going to end up doing a lot of work copying stuff. The other option is our typical copy to points. So I've got my grid here. I've just added some normals just to give my orientation correct. And then there we've got the copy to points, and you can see that works well. I mean, that's obviously great. It's fast and it's working. We would need to obviously now, if you think about it, compensate for the amount of copies as the walkway gets longer and shorter. So we'd have to try and deal with some kind of expression that would even these out as we stretching them. And that's possible, but it's also not ideal because we want, for two reasons, we want corners, and also we've got a walkway size. So imagine this is our walkway size, and what we want to be able to still do is add detail edging, and we want to add sides that go downwards, walls that go off to the sides and our stairs. So now we need to, if we're copying to these outer points, we need to try and somehow compensate for that. And that's not really going to be a very easy thing to achieve, because now our walkway is actually essentially much wider than the grid, and we'll have to then try and build our outer walls from the boundary of this, and it just becomes quite a lot more complex. Now there's another option, and quite an easy one, to get the grids to fit a little bit better within this space, is we can actually convert each of these ones to a point, get the center point of each of these primitives. And to do that, I'll show you a quick setup. It's not the most elegant solution, but it's quite a common one. So we can do a primitive split, and this will give you an error straight off here. It's got this name attribute you just need to disable. And what will happen is, if I view my points here, if I zoom into the point count, you'll see I disable it. I've got a point there, if you can see. I don't know if you can see it clearly on the recording, but there's a single point there. And if I enable it now, I've got a bunch of stuff that's overlapping. So it's basically splitting each one of these primitives out into its own primitive rather than a joined primitive. And then what we can do is we can do another operation called primitive properties. And let's just view that. And then on this primitive properties, we've got a transform. We can enable this, and then I can scale down each primitives. And as I do that, you can see it's individually scaling down each primitive. So I'm just going to ghost this or reference this top grid we've got going here. See if we can scale it down, and that's quite nice. And what you can actually do is just scale it down to 0. And now I've got effectively my center point. However, I've got all these 4 points now as one, in one center point. So that's not ideal. I've got now 80 points from my 20 primitives. So that's not ideal. So let's fix that. We can use what we call a fuse sub. And I'm just going to drop this. And then what I want to do is, you can see at the moment it's giving me no points. And by default, what it's doing is it's actually using a snap distance, which is fine since our points are all on top of each other. But there's some options down here, and this one, remove unused points from degenerate primitives. You need to just disable that, and you'll see we'll have now our points back. So now I've got 20 points, no primitives, they're just points now. And that's just because I've fused everything. So we've gone from 20 primitives to 20 points, and they're at the center of each one of these. Now I can plug this into my copy, and bam, there we go. We've got our primitives all in the center of this walkway, and that's getting somewhere. That's a little bit better. We would still need to compensate for the scale and stuff like that, and how we deal with that. But if I go here and I make a couple of extra points, and we can start playing around, and that kind of works quite well. That's quite quick and fast, and the only thing is they don't 100% fit into this, so we need to figure out a better way to deal with that. Now, just before we get to that, I wanted to show you another possible solution, which is almost working, that I tried to set up, and that's using this chain SOP. Well, the chain SOP is really cool. It's got some nice features, but it doesn't work off points as such. It builds its own points internally, and it actually works off curves or lines. So I've got this line here. Let's just disable my reference here for my grid. So I've got this line here, and then I'm plugging in my pavers. In fact, I'm plugging in all the 5-packed pieces of paver, all my variations, and I'm just going to enter this and view it, and you can see immediately. Let's just go out of wireframe mode. I've got a bunch of pavers, and maybe we can do a color on this just to help visualize things. I'm going to set this to random, and you can see automatically, without actually doing anything, set this to default, I've got random pavers traveling along this line, and that's quite nice. If I scale the line out and move it back, it's giving me a really nice result, and really nice and quick as well. And you can do a couple of things, like I had this fraction length of the curve, and that kind of tries to fit it more to the end of the curve. You can go here to cycle, and that will cycle the offset of each randomized one. So this is quite a nice start to something. We've got an offset here, and you can say piece spacing, so you can actually create little gaps between things. You can overlap them a little bit, so if you don't want any gaps. Some nice powerful features, and but this isn't entirely ideal for our setup, and I'll show you why now. So if I go and I want a corner here as such, or angle in the setup, I'm going to have to try and figure out a better solution. So at the moment, I've created this curve with this kind of almost 45-degree angle corner here, and then a straight end again. Just doing a resample node on it, so I've got a few more points in between. And then let's just plug that into our chain SOP and see what kind of results we get. So now you'll see some interesting little issues, and that's really only on the corners. As the corners approach, the pavers start offsetting in a weird way, and you get these kind of strange little issues happening. Wherever it's along a straight edge, this is copying perfectly. I mean, that's amazing. It would be nice if we could easily figure out why this kind of issue would happen, but it's still, I guess, not entirely ideal, because we've got quite a lot of overlap happening between these areas, even if they were lining up. So what we want to do is we want to look at maybe even a different solution again. And the solution, what I thought about initially and then started to develop on, was using this match size node. And if you unsure what the match size does, is I've got this, my paver, and this allows you to, at the moment, I've just transformed it randomly into a different space. So it starts off at origin. I'm moving it off into a random piece of space just to illustrate this setup. Let's just create a new match size node. Sorry, I wanted to connect it in here, like so. And if I view it, you can see immediately what happens is this node that I've transformed into randomly into space, wherever it is, by default, the match size is going to put it at the origin like this. Now, what's quite nice is there's a second input. And what it does is it takes the bounding object of the second input and it will utilize that. So I'm just going to delete this one. So if I take this grid that I've created, for example, and this grid is just also randomly in space, I can plug this into the second input and you'll see immediately, well, now my paver is actually centered within this grid, and wherever I move it, it's lining up. So that's quite nice. And what we can do is take it a little bit further on the match size. There's a couple of options. You know, we can do offsets and stuff like that. But there's also the scale to fit. And the scale to fit is quite cool. What you can do is just turn off this uniform scale, and you can see immediately what's happening is we're scaling the entire paver. If I go into wireframe mode, you can see there's a paver, and it's scaling to fit this grid. So that's quite nice. Now that gives us a bit more interest. The only problem is it's flat. So what we can do is just disable the scale on the Y position, which is our up, and we disable that. And now we've got our paver height back. So we're just essentially squashing and stretching it to fit this. Now, what's really nice about this as well is that this is still a piece of a packed geometry. So this is one point, and it's taking the boundary or the bounds of this pack primitive and scaling it into this match size. So I don't have to unpack it first and lose my efficiency. I can just take this pack piece of geometry and I can scale it up and down and move it anywhere in my scene. And, you know, it works really nicely. So now how can we do this and apply it to, say, this walkway top, for instance, like this? Well, what we can do is we can actually use this, we can use a for each loop. And this might seem complex, but it's not entirely that bad. So what I've done is I've taken my grid, I've done a sweep on here, and the sweep node gives me a couple of options of, let me turn off my point number display, and let's unreference this jobby. So I've set my shape. By default, you will get this error and it's looking for a second input, but you've got these sub options you can set to round tube or square tube or ribbon, and the ribbon's quite nice. It gives you a flat plane. At the moment, the primitives are reversed, that's why they're blue, so I can actually put a reverse SOP on here, and you'll see when I select that now they become gray, and now the bottom is blue. So that's the correct orientation for us to look at. And you can see now we've got individual primitives, and these primitives in between here are controlled by this resample. So if I increase or decrease them, I can get them, and let's try and make them squarish, something like that. And then we've got the sweep columns, and we can change the columns, amount of columns. At the moment I've got 2, and then we can control the width of the ribbon as well, which is quite nice. So going back to this for each loop, what we can do when you drop a for each, you can go for each primitive, and it will give you exactly this. And what it's doing is it's targeting each element, each primitive of a piece of geometry. So if I just view this, if I press information on here, you can see, you know, I've got quite a few primitives, and just looking at this, it's giving me well, this would be a single output. So if I view this, you can see it's got that single primitive. At the moment, I've actually set my, by default, sorry, I've set my pass, and you can set the single pass. So if I uncheck this, you can see now I've got, let's just middle mouse here again, 34 primitives. And over here, you can see listed 34 primitives. And this one over here gives you the previous piece. So it's saying 33, but there is 34 in output. And like I say, you can actually set this to single pass. So if we just template view this so we can see our geometry, and I can cycle through each one, each single pass. They're actually ordered based off their primitive number, which you could randomize as well. So there we go, we got each primitive. So now what can we do with this? So now that I've got the ability to get each primitive, I can essentially take my match size and I can use that. Each of these primitives, if I go here, got this primitive, I can plug it into my match size. And as soon as I do that, you'll see now my match size is included in this for each loop. And if I view that, you can see now my paver is locked into that scale of that primitive. Now what's quite nice about it, because it's in this loop and the output of the primitive count here is using the input as the value for iterations. If I just connect this here, even though I'm outputting a paver geometry, a packed paver geometry, if I view this and then I can cycle along and you can see I'm getting, untick the single pass, it will give me all my pavers. And now we copying all those pavers to the geometry. And if I go back to my sweep and adjust the width, we'll go to this resample and I adjust that. They're copying and scaling into that area. Sometimes the scale obviously isn't ideal. You've got, a little bit of stretching and stuff. But with a lot of variation and stuff like that, we can compensate and get away with a little bit of stretching. So we'll look at ways we can minimize that as we go. But the idea is to try and keep your primitive size sort of squarish, so you don't get too much stretching. Now there is one major issue. It's going to delete that, and that's that the match size doesn't take into account orientation. So if I look at this single one, actually just view the output and turn on my single pass again. And let's just go to a corner. This looks like a corner. Let's just ghost the reverse here. Go a few higher. There we go. We've got some corner points going. Now, as you can see, what's actually happening, if you look at this primitive, for instance, this is the primitive we copying our paver to. Just ghost that and keep the paver visible. It takes into account the bounding box of the object. So, for example, if I use a bound SOP, just to give you a visual idea, basically that's what it's doing. It's taking this bounding box and it's copying my paver to that bounding box size. So it doesn't see the orientation of the paver. It just sees the bounding box size of the paver and it matches that position, size, and location. So that's not ideal. So we need to figure out then a better method for actually doing a little bit of orientation. So we're going to be utilizing this method of the match size, but we're going to be taking it a step further, and we're going to be utilizing some of the tools that actually come with our rigid body dynamics setups. And don't worry about the nitty-gritty now. We'll get into that as we start building these walkways. So I just wanted to take you through some of those ideas and kind of start letting you think about maybe a possible solution. If you if you know Houdini, then maybe you have some ideas in your head. And but I'll show you the solution that I came up, the final solution that's based around this concept, and we will get to that when we start building our walkways.